Assalamu alaikum. My name is Azizul Rahman Mir and my student ID is 235173332. In this presentation, I will talk about automatic parking control systems, and this system monitor parking space ability to using digital logic and timer final state machine. And so let's explore how it's work, starting with the theoretical foundation. So, first of all, we talk about objective. The system has four key objective. First one is automatic monitor, track car entry and exit using sensor. Second one is real-time display, show full and space available on seven segment display. And third one is hardware efficiency, use triple five timer and flip flop for cost effective operations. And fourth one is scalability, design adaptable for large parking scale. So let's talk about the system overview. This system core component operate on this principle. So first one is the sensor. Infrared or inductive loops detect the car, and sensor generate the pulse, high or low, interpret as a binary input. Second one is counter logic, 3 bits synchronous up or down counter track for as regarding to my ID, and in flip flop D type store state and combination logic determine the next state. And third one, in triple five timer, stable mode generate the blinking space available signals, and the formula is F equals to 1.4 divided by R1 plus 2 into R2 and into C. So in one stable mode, whole full display continuously and the pulse wide, t equals to 1.1 r into c. And let's talk about the FSM. So ensure the correct timing, 4 meter seconds and on and off for display, and the state transformations on clock edges output are combinational. So in block diagram, here is the component interact. In input, enter and exit sensor feed into the counter and keep it set a max capacity like 7 car for 3 bits. And second one is processing. So in second one, co- commi- comparator check if the counter equals the capacity, and triple five timer one monostable for full, and triple five timer 2 for as stable for blinking space available. So in output, 7 segment display deriving by decode logic. So critical theoretical note, the duty cycle is 64% according to my ID, and is calculated from the ID value P equals to 2 plus 5 plus 1 plus 3 into 2 equals to 36. So we subtract with 100 and we got 64%. So let's talk about the circuit design. So in timer 1 monostable, our component R equals to 10 kilo ohms and K equals to 100 microfarad, and in operations trigger pull when the count equal capacity, and in second timer, which is stable, the component is R1 equals to 220 ohms and R2 equals to 217 ohms, and capacity capacitor was 250 microfarads. So the operation blink at 5 hertz according to my ID. F equals to 2 plus 1 plus 2 equals 5. So why this value? So derived from the ID based capacity calculation for TH equals to 85 millisecond, And in theoretical inside capacitor chose 50 microfarad to for 570 microfarad balance size precision. So let's talk about the FSM design and the Barley's port. The FSM ensured the precise timing and state 3-bit encoding as 0. So let's talk about the outputs. So A equals to not state third bracket to third bracket. So it will active S0 to S3, and in B state third bracket to third bracket. So it will activate S4 to S7, and in theoretical justification, the clock edges triggering ensure the synchronous state transitions and combination output minimize the delay for real-time response. Yes, and let's talk about the limitation and theoretical upgrades. So current limitations and their theoretical solutions. And 3-bit counter limited problem is it can maximum 7 per store, and the solution is use 8-bit counter. It can store 255 car with the carry logics, and second one is fix the duty cycle. The problem is hard coded 64%, and the solution is replace 555 timer with PWAM enabled microcontroller, and third one is sensor error. So problem is the noise cause miscount. So solution is added uh, scammy trigger for signal conducting. So upgrade the require um, revising timing and equation for FSM stage. So in conclusions, this design digital logic circuit foundations, counter timer, and FSM to solve the real world problem. And the 555 timer provide the reverse timing, while the FSM ensure the productivity and future work integrate the microcontroller for flexibility. So that's my time. Thanks for listening.